Okay, we are recording. This is Introductory Statistics, November the 9th, 2021. And now we need to look at the schedule. I will share my screen here. And today, being the 9th of November, we are starting into hypothesis testing. And as you see, we'll be doing hypothesis testing for the next month, basically, until we get to linear regression, and we'll do that for our last 2 weeks. So that's what we're doing right now. Homework set number 11 is due on Thursday. So that's what we're going to work on. And then next week, Tuesday, we have our test. All right, so let's see. Kimberly is here. And Dan Olson.
Hey, everybody.
All right, so the next thing would be questions. Now, what we're going to do, standard procedure here is that I would go through some examples, and then Dan would be specifically tasked to answering questions on the homework. But if there's some thing that's relatively, well, no, it doesn't matter whether it's any kind of homework question. If you want to tell me what your homework questions are, or your questions, and then we'll decide, Dan and I, how we're going to deal with it. So anybody have any questions about anything right now? That's all right. If you don't have any questions, we'll just go through the stuff that we have. And so, again, as I said, what we're going to do is I'm going to go through some examples here of the topic that we're doing, hypothesis testing. And, pardon me, what I want to do here then is to deal with what do we mean by hypothesis testing versus the confidence interval, okay? So we're going to start by asking the question, what is the purpose of the confidence interval? All right, so can anybody tell me what is the purpose of the confidence interval? You can either unmute yourself, type into the chat, or raise your hand, whatever you want to do. Now, my hope is that you wrote this down last time when we talked about what is the purpose of the confidence interval. And you might have written it down the time before that when I asked the question, what's the purpose of the confidence interval? And if you haven't written it down either that time or the time before that, You need to write it down now, and you need to have it in your mind. Okay? And Melinda says that it predicts a population measurement. That is correct. The purpose of the confidence interval is to predict population measurement. What is the purpose of hypothesis testing? It's not the same. Can someone tell me, based on notes or videos or anything, what is the purpose of hypothesis testing? Now, this is similar to the confidence interval in that I'm going to be asking this question a lot. I'm going to be asking this question a lot because it's important to know, what is this about? Why are we doing this? What's the purpose of hypothesis testing? We're not doing this simply to have you jump through some kind of a hoop in order to know something that you're never going to see again in your life. Hypothesis testing is the thing that statistics is used for. So that when people say, I want to know what to do in this situation, I want to use statistics, usually this is what they're doing. And so if you don't know what this is, then you're not going to really know what the purpose of statistics is. What are we trying to figure out? So it's really important to know what is the purpose of hypothesis testing. Okay. Nope. Sorry, Melinda. That's not what it is.
Okay, I have down for the purpose is for a population proportion to determine whether information from a sample drawing for a population supports or refuses a claim about the value of the population portion.
Okay, what you have is reasonable, Darcy, except it's only talking about proportions. Hypothesis testing is used for any kind of statistics, not just proportions. And what you have there is almost too general. Okay, you say it's proving something, but it's more, there's more to it than that. It's not just proving something. We're not just making statements and then proving them. There's a specific kind of statement that we want to make in hypothesis testing, and we want to be able to prove that particular kind of statement. Okay. And I would like to know what that statement is. What kind of a thing are we trying to prove? And the answer is proving a difference in a population measurement. So for example, if you ask a question, does this treatment for high blood pressure work or not? What you're actually saying is, okay, thank you, Leah. I appreciate you letting us know. Okay, so hypothesis testing, if you say something like, does this treatment affect people's blood pressure? You would say, well, either it does or it doesn't. But in statistics, we would have to say, can we show that this makes a significant difference and it's not just a random difference? Okay. If we ask a question, does it help a particular ethnic group to have incentives for home ownership? What kind of a difference does it make in that group? Well, we need to measure that, hopefully. And then we would need to say, okay, does it make a difference or does it not? And how we determine that is by comparing. And hypothesis testing is all about comparing some kind of a measurement to say, is this working? Does this make a difference or doesn't it? And that is generally what statistics is all about, that we're trying to figure out if there's something that makes a difference, and we want to prove that it's not just a random chance event, but that there's something different about whatever it is, whether it's a cancer treatment or a targeted money or advertising. Okay, all of us are subject to hypothesis testing all the time. People are asking the question, how can we get this person to buy this car or buy these shoes or buy this computer? They're constantly saying, what can we do that makes a difference? And that is what hypothesis testing is all about. Okay. Now, when we say that's the purpose of it, then we have to say, how are we going to make this happen? How are we going to make this happen is going to be from a specific set of steps. Steps for hypothesis testing. They are: step 1, create hypotheses. We're going to have a statement, some kind of a statement, and that's going to include a statement about a difference. Okay. Step 2, we choose the appropriate test. There's going to be some kind of a mathematical way to show that this is a thing or it's not a thing. You determine the test value. There's a number associated with the test. Then step 4, we find the p-value. It's associated with the test value. Now, steps 3 and 4, generally, if we use SALT, it does both of those things at the same time. So steps 3 and 4 are often going to be combined when we're using SALT, which we're going to be doing. And then step 5, we're going to draw a conclusion and interpret it. Okay? If you don't have these written down, you need to write them down. If you've not yet taken notes on this section, you need to write down these 5 steps. We're going to be using these 5 steps for the next 8 weeks. So you need to know them. You need to know how to do them. All right. So we're going to do an example, and we're going to talk about how this works. Example. Approval ratings for Joe Biden. Now, you may not be a political person. It may not be a big deal to you about Joe Biden and his approval ratings. That's fine. But that's what we're going to talk about. That's what we're going to use. We're going to use this example. So I'm going to go to one of my favorite websites and find their information about Joe Biden. And I'm going to share my screen so you can see it. I don't think I did that right. There we go. So now we have this statement, how popular is Joe Biden, or how unpopular? We see that his popularity has significantly changed, or at least looks like it's changed a lot over his term. Right now it stands at 42.8% approval. Now, when we look at the polls which have done this, there's this poll called the Rasmussen poll, which had his approval rating at 40%. The Morning Consult poll had his approval rating at 46%. And these were all conducted in just the past 3 or 4 days. So we have some real differences here of these different polls and how they work. So I guess we can pick pretty much either one. Let's do Rasmussen reports, okay? And they are giving Joe Biden an approval rating of 40%. Now that's a sample number, right? So we have a sample proportion of 40%. And we have a sample size of 1,500. So the question that we're going to ask, we want to prove that there's some kind of a difference here. Is there a difference of the population used by Rasmussen versus the overall population? Note that the question is about a population. It's not about a sample. We know about the sample. We have the sample. But what we're asking here is there a difference in how Rasmussen does their polling so that it's giving us a different number than what we would have expected from the overall population? So then what we need to do in order to make this work. And we're going to use alpha of 0.05. That has to be stated for us, and we'll talk more about exactly what that means. But let's see. Do I have that symbol anywhere? Oh, yeah, I can put it in here. Insert equation. Alpha looks like this. So alpha equals 0.05. Now, can anybody tell me something about creating hypotheses? I want to make hypotheses here. I want to be able to describe something about a standard value, and then I also want to describe a difference. So I need a standard value and a direction of. All right, can anybody tell me what I would use for what's called the null hypothesis?
Could you email the agenda? Because I can't see anything that you're typing, please.
I did already, Darcy.
Okay, I never received it.
All right, I'll send it again. So when you go to your email, you don't see something that says agenda. Is that correct?
That is correct.
All right. So if I go here, send email. And I'm going to specifically send it to you because I already did send it out to everybody else. selected. Agenda. All right, Darcy, did you get it?
No, I didn't.
Okay. So I don't know if you need to hit refresh on your email. Dan was having trouble earlier about his email, so it might be a specific problem.
Okay, I'll log out and log in. Thanks.
Okay. So all right, anybody able to tell me what a null hypothesis is and how I would make one happen right here? Okay, so a null hypothesis is the standard value that's based on the population number that we're comparing to. And so when we ask the question, what is the overall population? What we're going to do is we're going to use that 42.8% from the general population. And what we're going to do then is we are going to assume that that is number that is the same as the Rasmussen population. So we have 0.428. What does this actually mean? What this means is, this means Rasmussen population number is assumed to be the same as the overall number. So we're saying, let's assume that the Rasmussen population has the same number as our overall. That would be P is equal to 0.428. That's the null hypothesis. It's the standard number that's given to us for a comparison. The next thing that we do is an alternative hypothesis. Now, it is possible for me to go through this without ever asking anybody if you know anything about this. I'd prefer to have somebody else enter in here to describe for me what you do and don't know about this. If you don't know anything about this and you haven't watched any of the videos, then I'm going to go through it, but you know, that means we'll just go through it like it's on the video, which we can do. And sometimes that's necessary, and I understand. But if you know anything about what I'm doing, I would love it if you can just kind of enter in and help me out a little bit here. It's up to you, but it would be to your benefit if you can enter into this and say, I understand this, or I don't understand this, or I've seen this before, and this is the part of it I don't understand. Otherwise, I'm just going to keep talking, which I can do. I can do that. So the alternative hypothesis is now going to be something that looks like this. One. is less than 0.428. This means the Rasmussen population number is less than the overall number. Now, in constructing these, it takes some reading skill for you to know what direction we're talking about here. How did we come up with this? Well, we have a survey number of 40%. But we want to see if that would be an unusual event given a population number of 42.8%. So we're starting with an assumption of 42.8%, and then we're asking, is the 40 an unusual event to happen? Now, if we say it's an unusual event, it makes sense that we would say it's unusually low, because 40% is lower than 42.8%. So in your homework and on your exam, what you'll have is some kind of a description of the direction that you need to look at. Okay, Kimberly, thank you. So what we're looking at here then is this number that we have, this 40%, is it substantially lower than what's in the population? It could just be a random difference, or it could be something where there's an actual thing going on, that this group of people that Rasmussen is talking to actually have a lower approval rating compared to the general population. So what we want to do is we want to figure out, was this something that happened by chance, or is this something that did not happen by chance? And so what we're going to assume is if it's a low probability of happening by chance, then that's an indication that something significant is different about this. So that's what we're going to try to do, and we need to have a standard in mind, and we need to have a comparison in mind, what direction we're doing. Now, it's possible that we can have something called a two-tailed test. And if we have a two-tailed test, then two-tailed test would be that this proportion is not equal to 0.428. So what that would mean for us here is that we are not sure whether we're thinking about it being higher than or lower than. We don't know that. But when I construct a hypothesis, I base my idea on the fact that the sample number tells us what the real direction of it is. If it's 40% versus 42.8, well, then obviously we're wondering if this is a lower number. And so then we use the less than direction. But sometimes in the textbook, they say the word differ. Okay, so if we say this uses the word differ or different from. So it's just talking about being different, then that will be a two-tailed test. But if it uses words more than or less than, then we'll know which direction it is. All right, so that's the idea of differing. Darcy, did you were you able to get the email or not?
No, I haven't gotten it.
Okay, so what I'm going to do is I'm going to try to send it not through Blackboard, but through your actual email. If that works. Do you have an indication that your email has been working other than that, Darcy?
Yeah, I got an email at 4:31
All
from
right.
somebody else, so it's working.
All right, so I just sent you an email with that information.
Okay, I got it.
Okay. That's weird. Okay, so Kimberly also says that she's having trouble getting it, so. All right. So now I have alternative hypothesis here, and I have my null hypothesis. So that's giving me my hypotheses. I've done step 1 now. So now I'm going to go to step 2. This is choose the appropriate test. So we go to SALT. And I'm going to share my screen so you can see what SALT looks like. And we go to inferential statistics, one sample proportion. That's the appropriate test for us to use. Inferential statistics and one sample proportion. So now we need to figure out the number of successes and the number of trials. This information here is sample information. So if I have sample 1,500 and 40% approve of Joe Biden, what numbers go in to SALT? All right, I would like to know these results. Can somebody tell me what numbers I'm going to put into SALT? Melinda.
600. Oh, Melinda already
Okay,
typed.
Jamie too. All right. Jamie, how'd you get that 600? Jamie, can you tell me how you got the number 600?
I Googled it.
What did you Google?
40% of 1,500.
Okay. You could also take 0.4 times 1,500.
Sure.
That would work. All right. Now we're going to do a hypothesis test. So we see that's the radio button that's been clicked. And now we're going to click on the hypothesized proportion. The hypothesized proportion is the proportion which is in the hypothesis. So since this was 42.8%, this is 0.428. Then when we say alternative hypothesis, we then need to decide what direction we're going to go. So for this alternative hypothesis, we're going to pick less than. And then we generate results. So then, if we've done this correctly, what we will see here in the results will be what we need. The null hypothesis, you see H0, P is equal to 0.428. Alternative hypothesis H1, P is less than 0.428. Now your textbook also uses H sub A as the alternative. Either one is fine, but in the software, it's H sub 1. So we have chosen our appropriate thing. We have put the information into SALT, and now we have results. And then we say, okay, what does this mean? We have two things that we're looking for now. In step 3, we want to find the test value. What is the test value? The test value is a value of Z or T that indicates how different our sample is from what we expected. So we had an expectation of 42.8%, but it's not 42.8%, it's 40%. So if we ask the question, how different is that? Then that's what we're getting from the test value. And the test value, in this case, is the Z statistic of negative 2.19. Now, can anybody tell me what is the meaning of the Z statistic? When we get a Z statistic, what specifically is that talking about? The Z statistic is a measurement of how different a data value is from the mean. Specifically, it's the number of standard deviations away from the mean. Number of standard deviations from the mean. So how different is this? It is more than 2 standard deviations away from where we had expected it to be. So if we think about this, we would say, that's pretty far. If it's more than 2 standard deviations away, then that would be in a situation where we might consider it to be an unusual event. That's what the test value is telling me. But that's not enough for us, okay? In hypothesis testing, we actually need to find the p-value. The p-value has been misunderstood throughout its history. P-value indicates probability of having an extreme sample like ours, or more extreme. So what we're saying is, how likely is it that this particular sample happened by chance? But we are assuming standard population number. So if we say we assumed that our population out there is at 42.8%, how likely is it that we would get a 40% sample or even beyond that? And when we look in SALT, hopefully you can see that number. The p-value is 0.0142. So that is step 4. We have chose the appropriate test. We found a test value. And now we have a p-value. And now we come to what you might consider to be the hard part. And that is we need to draw a conclusion and interpret that. And once again, I can't force you guys to do things, right? I want you to learn how to do this. In order for you to learn how to do this, you have to write this down. And you have to be able to refer to it later. If you write it down on a sheet of paper and you turn the page and you never see it again, that won't help you. You need to have a way to organize your thoughts into a book, a notebook of some kind, where you would be able to take a note and you would be able to say, I know where this is, and I know that I can find it again. You have to be able to do that. Otherwise, you won't be able to learn how to do these problems. And you'll go through week after week and you'll say, oh, I don't know what the answer to that is. Well, you need to be able to look it up. If you can look it up, you can find the answer. And if you don't know what I'm about to tell you, you'll get everything else wrong the rest of the term.
Okay, I got
all of your
something-
conclusions will be wrong.
I got something for this part.
Okay, Darcy, what do you got?
Okay, if the p-value is less than alpha, we reject the null hypothesis, and there is enough to prove the alternative hypothesis. If p-value is greater, we fail to reject the null hypothesis. There is not enough evidence to prove the alternate hypothesis, is what I
Is
have.
correct. Okay, I'm just typing in here what you just said. Okay. So the p-value is telling us what to do, and it's telling us what conclusion to draw. And it's based on the idea of what is an unusual event. Okay. If this is an unusual event, then we would say our initial idea of having a 42.8% population is wrong, or there's evidence against it, okay? So what we want to do, our goal, okay, our goal is to reject the null hypothesis and say that there's evidence to prove the alternative hypothesis. The alternative hypothesis is that this Rasmussen population has a lower rate of approval for Joe Biden. Not just the sample, but that the population of the people that Rasmussen is asking, however they do that process, that what they're going to do is going to come up lower. And so we have proven that now. That's what our goal is. Now, a lot of people get messed up here for a number of different reasons. First of all, they think that rejecting something means we reject the idea. That's not what's happening here. We rejected the null hypothesis so that we could prove the alternative. Our goal is to prove the alternative. So when we reject the null, we prove the alternative. That's what we want to happen. And a lot of times people, when they get to this point, they say, we're going to reject it. That's a bad phrase to use, because when you say we reject it, I don't know what it you're talking about. We reject the null hypothesis and we prove the alternative. Every time you say reject the null hypothesis, the next thing you say is we prove the alternative. Then, if the p-value is greater than alpha, we do not reject the null hypothesis. There's not enough evidence to prove the alternative hypothesis. There's no decision here. We can never accept the null hypothesis. Or never is probably a bad word. This does not cause us to accept the null hypothesis. When we say I don't have evidence to prove something, I am not able to say yes or no. I don't know the answer to the question. I don't have enough evidence. Right now, this is such an unusual event that we say, okay, this is very different. It's more than 2 standard deviations away. There's a low probability of this. So since there's a low probability of it being a random chance, then I'm going to say there's a real distinction between the Rasmussen group and the overall population. So another way when we say the situation, if we do not reject the null hypothesis, this sample could be a random fluctuation. The sample clearly is different, but that difference could be just based on random chance. And the way that we decide, our standard by determining this, is that we have an alpha. We have this number, alpha, that we choose to say, this is what I'm going to say is an unusual result. Melinda, what would happen if they were the same? If they were exactly the same? Even if they're close to each other, then we might waffle a little bit. We might say, well, maybe it is. On a homework or on a test, of course, they're not going to be exactly the same, right? It's like asking the question, is it possible for me to draw a dot the size of a pin onto a target and have you hit it with a rifle from 300 yards? It's possible, but it's just not very likely, right? It would just be the purest chance. Waffles. Oh, thank you, Dan. Thank you for that visual, and more than visual, of course. Thank you for that experience, Dan. But it's highly unlikely that we would ever get something that would be exactly 0.05 or 0.10 or whatever else. All right. So now we're going to do this for our example. So, Jamie, can you tell me which of these situations we're in our example here?
I'm going to pass.
Okay. Melinda, can you tell me what situation I am in here with my example. We reject the null hypothesis. That's correct. Our p-value is 0.0142. Our alpha was 0.05. So we reject the null hypothesis. We say there's evidence to prove the alternative hypothesis. Now, when we say this, all right, we also need to describe this in the terms of what is the alternative hypothesis. What does the alternative hypothesis say? If you go back up into the agenda, it says this means the Rasmussen population number is less than the overall number. So then we would specifically say the population proportion of people surveyed by Rasmussen is lower, or that approve of Joe Biden is lower than the overall national number. So there's something going on with Rasmussen so that their number is coming out lower. It's not just a random thing. Certainly, if you go out and you do a survey, every time you do it, you're going to get numbers that are a little bit different. Every time you do it, every 1,000 people you talk to, it's going to come out as a different thing. But this is not the situation that we have here. What we have right here, this number is so much lower that it cannot be simply explained by sampling variation. It's not a chance event. There's something going on here, according to this, since it's a low probability of having this happen. This is therefore a difference. So something's going on. We don't know what it is, why Rasmussen is different, but it is. So now we've proven that. All right. So that is hypothesis testing. That's an example. All right, we're going to do another one. And since we don't have to explain the entire thing, it'll take us a lot less time. In a recent poll regarding support for national voting guidelines, the national number was 69%, but ages 18 to 35, it was 74%. So what would we be trying to prove here? Mary, can you come up with a statement for what we would be trying to prove in this situation?
What are we trying to prove? No.
Okay.
I'm not sure how to word it.
All right. Jacob, how about you? What would you come up with wording here? What would we be trying to prove? All right, Jacob, I'm hearing clicking noises, but I don't hear your voice. Well, we'll consider that something's gone wrong here. Okay. So, Melinda, can you tell me what it is that we would try to prove here? Yes, the support for national voter guidelines is higher for ages 13 or 18 to 35. So younger people would be more in favor of these voter guidelines. Okay. And we're going to say that the survey was 133 people. All right. So how we would set this up then? We would have our null hypothesis. All right. Actually, no, Melinda, the null hypothesis is based not on the survey of the youngsters, but on the national number. P is equal to 0.69. And I'm sorry, I should have put 133 young people. The survey number is not the number that goes into the hypotheses. You have to have the population number in our hypotheses. And notice it's not, the null hypothesis is not the number 0.69. The null hypothesis is a statement about the proportion. And as you said, Melinda, this would be greater than, so this is greater than 0.69. Now we did step one. We have our hypotheses. In step two, we're in SALT. That's what we want to do. And what I can do here, I need the number of successes, which is the mean or X or whatever you're going to call it, is equal to 0.74. Okay, Jamie, see you later. So I've got 0.74 times 133. Why did it not do that? 98. Okay. So then, we're going to put that into salt. And I will share my screen so you can see it. Oops. No. Window. Salt. There we go. So I'm going to change this to have 98 successes out of 133 trials. My hypothesized proportion is 0.69. I change this to greater than, generate results. And I see I have my null and alternative hypotheses as I've already listed them. My test value then is 1.17, z equals 1.17. And my p-value is 0.1214. And I did not put my alpha up here at the beginning, but we are going to assume that alpha is equal to 0.05 unless directed. All right. So Mary, now that I have my test value and my p-value, can you tell me what I'm going to do now?
I'm just looking back at my notes.
Okay, that's
So we're finding the test value.
we have the test value 1.17.
Okay, so that's the number of standard deviations away from the mean. So now the p-value.
We
which
found
we
the
had.
p-value
Then
is
we've got a conclusion. Let's see, and so our p-value is 0.12. So our p-value is less than the alpha, so we reject the null hypothesis.
okay, Mary. If our alpha is 0.05
0.05.
and the p-value is 0.1214, the p-value is greater than alpha.
Oh shit, how's that greater?
Possible that
Let's see how that's greater. 0.12.
is bigger than 0.05.
Oh, 0.5. Shoot, I had 0.5.
Okay, so it's
Okay.
0.05.
So if it's larger, if the p-value is greater than alpha, we do not reject the null hypothesis. There is not evidence to prove the alternative hypothesis.
Hey, that's correct.
Okay.
All right, so Melinda, what does that mean? It means that we can't prove anything. You are correct. Okay. So the question up here, which we had asked, was, is the support for national voter guidelines or voting guidelines higher for that age group? The answer down here is we don't know. Is it higher in the sample? Yes, it's higher in the sample. It's 74%. But that could have been just a random fluctuation. We don't actually know if it was higher or not. It could have been just a random thing. There is not enough evidence to prove that. Now, if we have a larger sample, then we can have better accuracy. Or if the numbers were just farther apart, then we would be able to do something. But they're not. We don't have a larger sample, and the numbers are not farther apart, so we can't draw a conclusion. No decision here. There's not enough evidence to prove anything. Can we say they're equal? No, they're certainly not equal. 74 versus 69? No, they're not equal. They're kind of close, all right, but we can't really say that what that is. And this is the advantage for confidence interval. If we used a confidence interval, we would be able to then say, where is this 74%? It could be higher or it could be lower. We don't know. And that goes back to what was on the project, for those of you that have done the project. All right, there we go. We made it. We made it through 2 examples. So now it's 5:20. We're going to take a break until 5:30. And Dan Olson is going to be able to go through homework at that point. All right, so I'm going to stop the recording.